Dear students, in electricity, you have already studied about the electricity and Ohm's law, etc. Now, in this period, you are going to study about two types of resistance connections in circuit. Okay, you have already know that what is resistance. So, resistance is a oppose to flow of current in the circuit. Okay, now in resistance correction we have two types of connections. One is series connection of resistors in series. First we shall study about the series connection of resistors in series. So now series connections means if two or more resistors are connected in circuit so that one end of the resistors to the other and that to the another, so on. This is called series connection of the resistances. One end of the resistance. Observe here, I am showing this is one resistance. Connected another resistance to the this end. This end connected like this. This is R1, this is R2, this is R3. If you connect these resistances in this way, so then that is called series connection. If two or more resistors connected circuit so that one end of the resistor to the other and that to the another and so on. This is called series connection. Okay. So now let the potential difference of R1 is V1. This is potential difference. The potential difference between the 2 points are here different. This is V1. This potential difference between these two is V2. Potential difference between these two is V3. Here potential difference between these three resistances are different. Okay. Therefore total potential difference in the circuit is given by V1 plus V2 plus V3. Total potential difference is given by V1 plus V2 plus V3. We know the Ohm's law, isn't it? We know the Ohm's law, V equal to IR. So therefore, here the resistors are series in circuit. Therefore, current is same. Therefore, we apply the Ohm's law. In the circuit, when it is connected in series, resistances are in series, then current passing through the circuit is same. Current passing through the resistances are same. So current passing through V1 equal to I1 R1, V2 equal to I2 R2, V3 equal to I R3. I current is same. So therefore V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So now add this V equal to V1 plus V2 plus V3. We know that V equal to total V equal to IR. So total V equal to IR. This equal to IR1, IR2, IR3. Take common I cancel I both the sides. Then you will get R equal to R1 plus R2 plus R3. That means if resistors are connected in series, then the total resistance is sum of those resistances. Sum of those resistance. For example, if 2 ohm, 1 ohm and 3 ohms are connected in series, then total resistance of that series equal to 1 plus 2 plus 3, that is 6 ohm. Okay. So here resistance is added. So therefore the resistance are connected in series, then the resultant resistance is sum of all the resistances in series. Okay. So therefore R equal to R1 plus R2 plus R3 plus R so on. So when resistance are connected in series, then this is the ray diagram to show that how to connect in series. So this is R1, R2. You know that voltmeter is connected to parallel to the circuit. So here voltmeters are connected in parallel to the circuit. Ammeter is in parallel in series with the circuit. So this is ray diagram, remember, and also write carefully. Okay. So now here current through the resistances are same I. So here current through the resistances are same, but potential difference are different V1, V2, V3. Okay. But potential difference are between the resistances are different. So this is another type of, we can write like this also. V1, V2, V3, these are the resistances, you know that. We can show this also. But this is this type of symbol is not in your textbook. Okay. So now problem. 20 resistance electric bulb and conductor having 4 ohm are connected in series. Show in the circuit as shown below with 6 volt battery. Find the total resistance and current in the circuit, potential difference between the electric bulb and conductor, and show V equal to V1 plus V2. So try to understand this. Here 4 ohm resistance and another bulb. Bulb is also having resistance 20 ohm are connected in circuit. We have to find out the total resistance and also find out the potential difference V1 and V2, and also we have to show that V equal to V1 plus V2, and also we have to find out the current. So let us calculate one by one. So now first find the total resistance. Because this is in series, you know that R equal to R1 plus R2. So 20 ohm plus 4 ohm, 24 ohm. This is very easily you can calculate. So now we have to calculate I. I, how can you calculate? I equal to V by R. V equal to 6 volt. This is 24. 6 by 24 equal to 0.25 ampere. Total potential difference is 0.25 ampere. So you know that when resistance are series, then potential difference are different. That is V1. So V1 equal to IR1. V1 equal to R1 is 20 ohm. So 0.25 into 20, you will get 5 volt. So V2 equal to IR2. I is same, 0.25 into 4. This is 4. 4 is given. So 4 into 100, you will get after 2 decimal, 2 digits you have to put decimal. So 1 volt. So 5 plus 1 total we can find out now. V equal to V1 plus V2, 6 volt. 6 volt is given now. 6 volt is given. So we will get 6. So total VE1 plus V2 equal to 6. This is how you can verify. So go through once or 2 times, you can understand. Okay. Parallel connections. Parallel connections means if 2 or more resistors are connected parallel to the series, so that the end of the resistance are connected between the 2 points, like this. Here connected, these are connected to a single point. Here potential difference between these 3 resistors are same. Potential difference are same, but current are divided into I1 plus I2, I3. I is divided, current is divided into I1, I2, I3. Okay. Here potential difference same, but current is different. So that is I1, I2, I3. So now here I equal to I1, I2, I3. So applying the Ohm's law, V equal to IR, I equal to V by R. So applying that, so I equal to V by R, I1 equal to V by R1 plus V by R2 plus V by R3. Now take V common, R cancel V. So now you will get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. That means if resistance are in parallel, then total resistance is equal to the reciprocal of the sum of the resistances which are in parallel connection. So when resistance are connected in parallel, the resistance decreases. Potential difference is common. The current through the resistance varies. Okay. These 2 points are very important. Here 1 by R1 R equal to, when connected in parallel, then resistance equal to 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. For example, if 1 ohm, 2 ohm, 3 ohm are connected in parallel, then total resistance is 1 by R equal to 1 by 2 plus 1 by 3, 1 by 1 plus 1 by 2 plus 1 by 3. You know the how to calculate fraction. So, okay, take that reciprocal, then you will get the resistance. Resistance decreases. Okay, on that I have shown a experiment when 2 resistors are connected in series and when 2 resistors are connected in parallel. What is the difference? The bulb glows very low when connected in parallel. That means current decreases, resistance increases. Okay. So now this is the parallel connection. So go through this parallel connection. Here potential difference is same because connected to a same point, but current is divided into I1, I2, I3, etc. Okay. So this is ammeter. So this is the diagram. Go through now. So now here is one problem again. So 5 ohm, 10 ohm, 30 ohm are respectively. They are connected 12 volt battery. Find the total resistance and show the I1 plus I2 plus I3. I equal to I1 plus I2 plus I3. So see here, this is the figure. 3 row resistance are drawn like this. So now, so total resistance 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Take 1 by 5, 1 by 10, 1 by 30. Down 30 is the LCM. So 5, 6 the, so 6 1 the 6, 10 3 the 3, 30 1 the 30. So 6 plus 3 plus 1. So 10 by 3, you will get 1 by 3. So take reciprocal R equal to 3 ohm. 1 by R equal to 1 by 3. Take reciprocal, this is important. R equal to 3 ohm, not R equal to 1 by 3. 1 by R equal to 1 by 3. So therefore R equal to 3 ohm. This is the resistance. Here 5 ohm, 10 ohm, 30 ohms resistance are connected, but resistance is decreases to 3 ohm. If they are connected directly to the in series, then the resistance is 30 plus 10, 45 ohm. Resistance becomes high. So here resistance becomes decreases. Okay. So now calculate I equal to V by R. V is 12 given. R is 3 ohm. We have already calculated. Therefore 4 ampere. Total current is 4 ampere. So now I1. V is 12. R1 is given 5. So 2.4 ampere. Similarly calculate I2. V by R2. 12 by 10. 1.2 ampere. I3. 12 by 30. So 0.4 ampere. Add this I1, I2, I3. So you will get 2.4 plus 1.2 plus 0.4. You will get 4 ampere. Here also 4 ampere. So therefore we can say I equal to I1 plus I2 plus I3. So okay. So now difference between the series connection and parallel connection. Series connection, resistance increases. Here resistance decreases. Total resistance is given by when series R equal to R1 plus R2 plus R3. Here total resistance is given by 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here the current passing through the resistance are equal. Here current passing through the resistance are different. That is I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. Here potential difference between the any 2 points of the resistance are different. That is V1 equal to I1 R1, V2 equal to I2 R2, V3 equal to IR3. Here potential difference between the 2 points of the resistances are equal because they are connected to the same point. So therefore potential difference is same. So these are the difference between the series connection and parallel connection. Here is a problem. So very interesting problem. Here find the total resistance. So here these two are in parallel. So therefore we can add resistance in series. RS means resistance in series. R1 plus R2 you will get 12 ohm. But these two are in series. But these two and this are in parallel. So therefore first find out these two in series. These two are in parallel. So therefore RP total in parallel equal to 1 by R3. R3 is this one. 1 by RS. This is not R1. RS. RS is 12. So therefore 1 by 12. So 1 by 6 plus 1 by 12. You will get 12 as LCM. 2 plus 1 3. 3 by 12 1 by 4. So therefore RP equal to 4 ohm. Total resistance of this circuit is 4 ohm. Okay. I will show another one. See here, observe here the figure. Here, these two are parallel. These two are parallel. These two are in series. Therefore, so first we have to parallel. First we have to find out RP1, parallel 1. 1 by 6, 1 by 6. So 1 by 6, 1 by 6. 1 plus 1, 2 by 6. So 1 by 3. So that is resistance. This resistance is 3. 3 ohm. So again, here these two resistances are in parallel. These two are in parallel. So first we have to find the total resistance of these two. That is, these two are in parallel. So therefore 1 by Rp1 equal to 1 by R1 plus 1 by R2. So that is 1 by 6 by 1 by 6. Denominator same. So therefore 1 plus 1, 2, 2 by 6, 1 by 3. So that is Rp. This total resistance is 3 ohm. Okay. This total resistance is 3 ohm. See, similarly here 6 plus 6. So Rp2, R3 plus R4 are also in parallel. 1 by 6 plus 1 by 6, 2 by 6, 2 by 6, 1 by 3. Again this is also 3 ohm. So therefore these two set are in series. Therefore total resistance in series equal to Rp1 plus Rp2. So 3 plus 3, 6 ohm. Okay. So this is the total resistance of this circuit. Okay. Thank you. Now your homework. Here 3 problems are given. Write ray diagram. 4 ohm, 12 ohm and 24 ohm resistance are connected in series in the circuit with the ammeter, voltmeter and battery 120 volt. Find the total resistance. Find I. Show that V equal to V1 plus V2 plus V3. Okay. Similarly, write ray diagram. 4 ohm, 12 ohm and 24 ohm resistors are connected in parallel in the circuit with the ammeter, voltmeter and battery 120 ohm. Find the total resistance. Find I and show that I equal to I1 plus I2 plus I3. Similarly, write the differences between the series connection and parallel connection. So thank you. One more period is there. In that period, we are going to study about the Joule's law or heating effect of current. Okay. Thank you.